right, today what we're going to do is we're going to create the unit circle. And in the past, what we've done with angles has combined putting angles of rotation onto the XY plane. So we've taken some geometry and we have mixed it with some algebra. And we're going to do the same thing now, except we're going to take our special right triangles and we're going to put them on the XY plane. But even better than that, we're going to inscribe them in the most famous circle in the universe. And the most famous circle in the universe is the unit circle. And the unit circle is called the unit circle because it has a radius of 1. Okay, which means this distance here is 1. All right, so we're going to take our special right triangle, and I'm going to have one of the vertices at the origin, and one of the other vertices here is on the unit circle, which I said has a radius of 1. So what I did was I took the liberty of taking my triangle and putting it out here so we could work with it a little bit. But before we work with this one, I wanted to talk about this distance here is x. We're going to call that x. And this distance here we're going to call y, which makes this point right here on the unit circle x comma y. And we're going to use our knowledge of our special right triangle relationships to figure out what that point on the unit circle is, if this angle here is 30. So what is the relationship between the sides of a special right triangle that's 30, 60, 90? Well, the side opposite the 30 we usually call x. The side opposite the 60 we call x root 3. Now this x is different than this x here, obviously. This is just the relationship between the sides here. And then the hypotenuse is always 2x. So where's our information? Our information is on the hypotenuse. And so I can solve this relationship here for x. So I can say that 2x is equal to 1, so x equals 1/2. Which means this distance here is equal to 1/2. So I know that height is 1/2. And then this distance here, or this side, the length of this side is root 3 times 1/2, which is root 3 over 2. Okay, which means my point here on the unit circle is going to be this distance here, and I'll use color here. So this distance here, which is root 3 over 2. I know these triangles aren't to scale, but this is also root 3 over 2. And then the y that goes with it is this distance, which is 1/2. So I can say that my point here is, instead of xy, I can say it's root 3 over 2, comma 1/2. Okay? So that's the point right there. If my angle is 30 degrees and I have my 30, 60, 90 triangle oriented this direction. All right, so let's see if we can find something interesting with the sine, cosine, and tangent, because we can use those relationships of the opposite over the adjacent, the opposite of the hypotenuse, adjacent over the hypotenuse, and let's see if we come up with some interesting numbers using this triangle here. Well, the sine of 30 would be the opposite, which would be our 1/2 over our hypotenuse, which is 1. And so we get the sine of 30 is 1/2. Let's figure out what the cosine of 30 is. Well, the cosine of 30 is going to be the adjacent, which is root 3 over 2, over the hypotenuse, which we designated as 1. And that's equal to root 3 over 2. And the tangent of 30 is going to be the opposite over the adjacent, I'm sorry. So it'd be 1/2 over root 3 over 2. And if we were to simplify this a bit, we could say it's 1/2 times 2 over root 3, which is equal to 1 over root 3. And if I were to rationalize that by multiplying it by root 3 over root 3, I get root 3 over 3. So the tangent of my angle is root 3 over 3 if my angle is 30 degrees. Well, the reason I like to go over this or bring this up is that we've seen these numbers before. Haven't we seen this number before? And this number before? Well, the answer is yes, we've seen them before. We've seen them right here. This is what our point is. So what's really neat about having a radius of 1 is I can say that this point is not only root 3 over 2 1/2. It's equal to, where's a good place to write this? It's also the cosine of 30 degrees, comma the sine of 30 degrees. So we have two representations. So if I know the cosine of my angle and the sine of my angle, I actually, if my hypotenuse is 1, I know the point here, which is root 3 over 2 1/2. Pretty neat. Well, we have a different kind of special right triangle, so let's get to that one. That one is the 45, 45, 90. And we're going to do the same thing. We're going to find this point. I'm going to call x, y, right? Because this is x and this is y, this distance. And this will be a 90-degree angle here. And my hypotenuse is still 1. So let's do some work here. So what is the special right triangle relationship with the 45, 45, 90? Well, you'd be right if you said x, x, x root 2. And if we wanted to find what x equals in this relationship over here, we would set x root 2 equal to 1 and solve that, and we would say x equals 1 over root 2. And if I were to rationalize that by multiplying it by root 2 over root 2, we would get root 2 over 2. So then I know that this distance here is, or this length of side is root 2 over 2. And since this one is the same as the isosceles right triangle, this would be root 2 over 2 as well. Which makes this point up here on our unit circle root 2 over 2, root 2 over 2, if I have a 45-degree angle. Well, let's see if the same relationships hold true here. Let's see. Let's figure out what the sine of 45 is using our 45, 45, 90. So the sine is going to be, if I use this as my angle, the opposite, which is root 2 over 2, over our hypotenuse, which is 1, and that gives us root 2 over 2. Let's find out what the cosine is. Well, the cosine is going to be the adjacent, which would be root 2 over 2, over the hypotenuse, which is 1. And the tangent of 45 is going to be the opposite of the adjacent, which would be root 2 over 2, over root 2 over 2, which is 1. Now, where have we seen these numbers before? Well, you know where I'm going, right? Because there they are right there, root 2 over 2, root 2 over 2. So we can say the same thing here. We can say that this point is also the cosine of 45 degrees, the sine of 45 degrees. Which is pretty cool. All right. Now, we did our 30, 60, 90 triangle this direction, but we could also have rotated it. So instead of the 30-degree angle being at the origin, we could say that the 60-degree angle is at the origin. And we can call this x and this y. And this point then here would be x comma y. And obviously my hypotenuse is 1. And let's use our special right triangle relationship, which is going to be, if this is the 30, the x goes opposite of the 30. The x root 3 goes opposite the 60, and we get 2x on the hypotenuse. All right, and I'm going to solve for x here. And we're going to get 2x equals 1, x equals 1/2. So I know that this bottom length of the triangle here is 1/2, and this leg here is going to be root 3 over 2. And you'll notice that the points have flipped. And this happens with complementary angles, and 30 and 60 are complementary angles. And it makes sense that they would flip because, you just flip the orientation of the triangle. So obviously the the lengths of the legs aren't going to change. They're just going to be in a different location. Okay, so this point on the unit circle then at the 60-degree angle is going to be 1/2 root 3 over 2. And let's figure out what the sine of 60 is, but I bet you could figure that out. So the sine, if this is my angle 60, is going to be the opposite, which is root 3 over 2, over my hypotenuse, which is 1. So it's going to be root 3 over 2. The cosine of 60 degrees is going to be the adjacent, which is 1/2, over the hypotenuse, which is 1, so it'll be 1/2. And the tangent of 60 is going to be the opposite over the adjacent, which would be root 3 over 2 over 1/2, which is equal to root 3 over 2 times 2 over 1, and those 2's cancel, and we just get root 3. All right, you know where I'm going. Where have we seen these numbers before? Well, you're right, over here. So I can say this point is also known as the cosine of 60 degrees, comma, the sine of 60 degrees. Almost as if I know the angle, I know the point on the unit circle. And that is truth. Okay, well, what can we do with this information? So what have we done? We've taken our special right triangles and we've placed them on the xy plane, inscribed them in the unit circle where the hypotenuse has a length of 1. And then we're very easily, using the special right triangle relationships, able to calculate some points on our unit circle. Well, oh no, that looks pretty busy. That looks pretty scary. But no, we're not afraid. We're going to now take our special right triangles that we put on the unit circle, and we're going to rotate them around. Okay, so the first triangle I'm going to put on here is our 30, 60, 90, where the very one we did first. And I want you to notice that this 30, 60, 90, where this is 30, and I'm going to put 30 degrees here. We know what that point is. We figured out what that point was, didn't we? We said that point, if we go back in time, we said that point was root 3 over 2, 1/2. So I'm going to put that on my, so I said root 3 over 2, 1/2. And I'm sorry I'm writing small, but we need to do that because I wanted to get the whole thing in the screen here. Okay, now I could take this special right triangle and I could reflect it over the y-axis, which is what I'm going to do. And I'm going to draw it this way. I don't know how long my pencil's going to last here. This color needs to last at least 4 triangles. So there we go. Where this angle is 30 degrees. Okay. But that's not my angle of rotation. My angle of rotation is going to be from here to here. Okay. So if this triangle has an angle here at the horizontal of 30 degrees, what is this big angle here? Well, it's going to be 180 minus 30, which is 150 degrees. Okay, so we call this angle right here, inside of this triangle that I rotated, a reference angle. And I'll talk about more about reference angles in just a little bit. Okay, but do I know what this point is? Well, this is still the same 30, 60, 90 triangle that I had over here. So this distance is going to be the same, or this length is going to be the same, and this length is going to be the same. But what's the difference? The difference is this one is in quadrant 2. So if I was going to describe the path to get from here to here, I would have to use a negative x value, which means instead of being root 3 over 2, 1/2, I'm going to be negative root 3 over 2, 1/2. Now that doesn't mean the length of the side is negative. It just means I went in the negative direction on the x-axis. Okay? So I can then take my triangle that I reflected over the y-axis. I can now reflect it over the x. And we'll get a triangle In the third quadrant, that is essential, has the same measurements, and this is 30. This is my reference angle, 30. And now my angle is going to be, instead of 150, it's going to be 30 more than 180, which is 210. Okay? But I know this distance. I know this distance is root 3 over 2, and I know this distance is 1/2. But I went in the negative x direction, so it'll be negative root 3 over 2, negative 1/2, because I'm in quadrant 3. And all the x's and the y's in quadrant 3 are negative. All right, and then the last time, I can take this and reflect it back over the y again, and I'm going to get a triangle in quadrant 4 with a reference angle of 30 degrees. And this angle is going to have a terminal side in quadrant 4. Oops, my pencil's going. And what is that angle going to be? Well, it's going to be 30 short of 360, so it's going to be 330. Okay. Now, what are the coordinates of that point? Well, the coordinates at that point are, I went over root 3 over 2 in the positive direction, and I went down 1/2, so it would be negative 1/2. All right? So those are the standard values on the unit circle. These points refer to me rotating the triangle around, which is pretty cool. All right, so we're going to do the same thing with our next triangle, which will be the 45, 45, 90 triangle. And I'm going to use green, I think. Okay, so I'm going to take my 45, 45, 90 triangle. And now this angle here is 45. And what is the point at 45? Well, if we go back in time, roll back the tape of the lines, notice that the point here is root 2 over 2, root 2 over 2. So that means I'm going root 2 over 2 to the right and root 2 over 2 up. And I know that point's root 2 over 2, root 2 over 2. So what happens when I rotate this 45, 45, 90 into quadrant 2? Okay, so my angle of rotation for that one's going to be 45 short of, and I'm sorry about that's not very round, but that's 45 short of 180, which will be 135. Okay, and that point, since I went left and then up, would be negative root 2 over 2, root 2 over 2. So this is negative, so we can see the negative. Okay, similarly, rotating or flipping the triangle down into quadrant 3, the angle of rotation here, I'm running out of space, is going to be 45 more. 45 more than 180, which would be 225. And then this point is going to be negative root 2 over 2, negative root 2 over 2. And following the same pattern, this angle is going to be 45 more than 270, which will be 315. And this point in quadrant 4 is going to be root 2 over 2. X is positive, and then y is negative, so negative root 2 over 2. All right. Now we're going to go blue. So hopefully blue will show up a little bit better. All right, so now let's do the 60s. So this is a 60-degree angle. Now what do we do with the coordinates? If we've changed now, this is the 60-degree angle down here. This is now the 30. And if you recall, what happened to the coordinates? Well, they just flipped from root 3 over 2, 1/2 to 1/2 root 3 over 2. So that's what we're going to put here, 1/2 root 3 over 2. Okay. And then what happens if I put the 60-degree angle in quadrant 2? that angle is going to have an angle of rotation that looks like this. And that'll be 60 less than 180, which is 120. And since I'm in quadrant 2, the coordinates are going to be a negative x value, so negative 1/2, and then a positive root 3 over 2 because we went over negative x and up y. And then if I were to go down into quadrant 3, this is going to be 60 degrees more than 180, which is 240. And that's going to be both negative 1/2 and negative root 3 over 2. And then if we go down here to quadrant, my circles aren't uniform. Anyway, this is going to be 300, right? Because you're 60 short of 360. So yeah, so this is 300, and this is going to be 1/2, because x is positive, and then I went down, so negative root 3 over 2. Okay, so we're almost, well, we're maybe 3/4 of the way done labeling our unit circle here. So let's talk about the other angles on this lovely busy piece of paper here. Well, this is going to be 0 degrees, right? Because we're going to start at 0 degrees, and then we would rotate to 30, and then rotate to 45, and then rotate to 60. So this, if I were to rotate to this terminal side, it would be 90 here. And then we went 90, and we rotated again, 120, 135, 150, and then we know that this angle is 180 degrees. And then we went to 210, 225, 240. This one is going to be 270 down here. And then 300, 315, 330, and then this would be 360 degrees. Okay, now let's talk about radians, and I'm going to go red for radians. Well, this is 0 radians, we know that. And we did a Smarties lab where we determined that halfway around a circle, the radians were pi, right? Because 180 corresponded to pi. So if I go halfway around, which is at the 90 degree mark, if this is 0 to pi, this has to be halfway, so this will be pi over 2. It's a little blurry, maybe we can get it less blurry. There we go, pi over 2. Well, if this is from 0 to pi, then this is going to be 2 pi if I go all the way around. And halfway between pi and 2 pi is 3 pi over 2. Okay, so 3 pi over 2 equates to 270. Now, I like to do the fourths next, okay, because if I go from 0 to pi and I divide it into fourths, right, this would be pi over 4. Then I'd get to, so this is 1/4 or pi over 4. This would be 2 pi over 4. This would be 3 pi over 4. And then this would be 4 pi over 4. And then if I were to rotate more, this would be 5 pi over 4. And then if I rotated more, this would be 6 pi over 4. Fourth more, this would be 6 pi over 4, which reduces to 3 pi over 2, right? And this would be 7 pi over 4. And let's see if it makes sense. If I go a fourth more from 7 pi over 4, I get 8 pi over 4, which is 2 pi. And then I like to divide my quadrant, or my upper half, into sixths. So if I were to divide 180 by 6, I would get 30 degrees, which is, oddly enough, my very first angle here. So if I divided this into 6, the first sixth would be 30 degrees. So this would be pi over 6. And then I would go another sixth, which would be 2 pi over 6, which would equate to pi over 3. And then if I were to go to another sixth, I'd get 3 pi over 6, which equates to pi over 2. So I've gone 1/6, 2/6, 3/6. This would be 4/6, which would be 4/6, which would be 2 pi over 3. And then I go another sixth, which would be, so this was 1, 2, 3, 4, 5 pi over 6. And then I would be at 6 pi over 6, which makes sense because that's 1 pi. And then if we rotated another 6, we'd be at 7 pi over 6. And then it would be 8 pi over 6, which reduces to 4 pi over 3. Then another 6 would make us 9 pi over 6, which reduces to 3 pi over 2. And another 6 would be 10 pi over 6, which reduces to 5 pi over 3. And then the last sixth would be, if this was 10 pi over 6, this would be 11 pi over 6. And see if it makes sense. If I go one more sixth, I would be at 12 pi over 6, which is 2 pi. Oh, well, that's great. So I've got all my radians marked. Now, you'll notice that I don't have some other points on the circle marked. Well, this circle is a unit circle and has a radius of 1. So the distance from here to here, from the origin to the outside of the circle here is 1. So to travel here, I would have to go 1, and I don't go up any point, so the y here is 0. What about this point up here? This point on the unit circle would be 0, 1, because I didn't go any in the x direction, but I went up 1 in the y. This way I went left 1 and didn't go up any. And then down here, which we can barely see, would be 0, -1. Okay. So we've got our entire unit circle now filled out, which is pretty busy, but it's not difficult at all. And the truth of the matter is, if I only know the first quadrant values, do I know the points of the other quadrants? And the answer is yes, because the x value, if I were to write a point on this one, the x value is positive, the y value is positive in quadrant 1. What about quadrant 2? Quadrant 2, the x value is negative, the y value is positive. Okay. In quadrant 3, they're both negative. And in quadrant 4, the x is positive and the y is negative. And before all of this started, this madness of this picture, we came to a conclusion, didn't we, that this point here, root 3 over 2, 1/2, is also the cosine of 30, the sine of 30. So I can say that the points are going to be the cosine of theta, sine of theta, no matter what my theta is. Okay, now I want to stress that the thetas are the angles of rotation where the terminal sides, are in quadrant 2, quadrant 3, quadrant 4. Okay, and that the x value and the y value, even if they're positive or negative, determine which quadrant your terminal side of your angle is in. So an angle, if I were going to draw 120 degrees, if I were to draw 120, the cosine of 120 degrees is going to be -1/2. And the sine would be root 3 over 2. Okay, so I'm going to prove it to you a little bit with my calculator, if you don't mind. And I'm going to clear this out. I am in degree mode, and I'm going to type in the cosine of 60 degrees, right? So I'm going to go to cosine and type in 60 here. Whoop, that's not right, 60. And you'll see that it's 1/2. Okay, let's try the cosine of 120 degrees. So cosine of 120. That's -1/2. Now we expected that, because the terminal side of this angle of 120 is in quadrant 2. So the cosine of the x value is going to be negative. Okay, what about the cosine of 240? So let's do that, cosine of 240. Well, guess what? That's -1/2 also. Well, of course it is, because the terminal side for angle 240 is in quadrant 3. And so the x value there is negative. And if I were to do the cosine of 300, you'll notice it's positive again. Why? Because the terminal side of the angle 300 is in quadrant 4, and the coordinate is positive in the x direction. Now, the angles 120, 240, and 300 have the same alpha, which is the reference angle, and the alpha is 60 because the 60 is the point. At 60 degrees, that gave us the point for each one of these, except all we needed to do is change the signs for what quadrant our terminal side was in, okay? Now, some people have trouble remembering what the points are, because we have to know the standard value points on the unit circle as well as we know multiplication tables, which you're going, oh, do we really? Yeah, we do. So I have this technique called the hand trick. And what I do is I take my hand, which is way too big for this graph, but you'll get the point here. Because if we know the first quadrant, we know them all. So here it is. I'm taking my hand and I'm laying it on the first quadrant. Do you notice here that my thumb happens to be the x-axis and my pinky finger happens to be the y-axis? Well, conveniently enough, my pointer finger is the 30-degree angle. My finger that shall not be named is the 45-degree angle, and my ring finger is the 60-degree angle. God works in mysterious ways. Anyway, so let's say I was having trouble remembering what the points are. Well, what I do is I will take my, let's say I want to know what the point is at 30, okay? 30 degrees. I take the 30-degree finger, which happens to be my pointer finger, and I put it down. Here it is. I'm putting it down. That instantly becomes a comma because it's kind of curled. It looks like a comma, right? Well, in my mind, I do this. I say, okay, pretend on my hand here, I have divided by 2. The older I get, the more wrinkly my hand is, so we're going to have to deal with that. But here we go, divided by 2. Okay, so I have put down my pointer finger at 30 degrees, and I in my mind have over 2 on the base of my hand here. So I'm going to suggest to you that the point at the 30-degree angle is the square root of how many fingers you got up. Well, how many fingers you got up here? 1, 2, 3 on the left side of the comma. So that's root 3 over 2, comma, square root of 1 is 1, so 1/2. Let's see if we're right. Root 3 over 2, comma, 1/2. It works. Pretty cool. All right, let's try another point. Let's say I wanted to know the point at 45 degrees, or pi over 4. I would put down the finger that shall not be named, and that's now my comma. So how many fingers do I have up to the left of that? That's root 2 over 2, comma, root 2 over 2. And sure enough, that's the point, root 2 over 2, root 2 over 2. All right, so let's say I want to know the point at 60 degrees. Here we go, I'm putting it down, my ring finger. So I take the square root of the number of fingers I have up, which is square root of 1, so it'd just be 1/2, comma, root 3 over 2. 1/2 root 3 over 2. It's amazing how it works. And if you know the first quadrant, you know them all because all the points are the same. You just have to know or remember what side your terminal side, what quadrant your terminal side is in. Okay, now it even works for quadrantals if you'll work with me here for a minute. Let's say I want to know what the point is at 0. Well, which finger would I put down? I would put down my thumb, which instantly becomes a comma, and I'm challenged to put down my thumb. There it is. Okay, so how many fingers do I have up left of my thumb? I have 4. So the square root of 4 is 2. 2 over 2 is 1, comma, how many fingers do I have up? 0. So the point's 1, 0. Ooh, pretty cool, right? Okay, here we go. Now, what if I wanted to be at 90 degrees or pi over 2? I'm going to put my pinky finger down, which is instantly my comma. And how many fingers are up on the left side? Well, 0. So my point 0, comma, root 4 over 2, which is 2 over 2, which is 1, 0, 1. So it even works for the quadrantals, which is pretty neat. Okay, so that's what I call the hand trick, and makes it easy for us to remember how to do these points on the unit circle. Okay, so what I suggest that you do is take time and practice, writing the unit circle. I'm going to have some blank ones on my homework site that I suggest you try to fill it out in 5 minutes. Okay, because without, I know the first couple you're probably going to have to look back, but the faster and the more that you can do this, the better that you'll be having it memorized, like your multiplication tables. Okay. All right, so I wanted to talk a little bit about the homework and some language here. Okay. So I'm going to do the first two with you in the first section. So it says, for number 1, sketch the angle on the coordinate axis, name the quadrant, draw the reference triangle for the angle, and state the measure of the reference angle, alpha. Okay, if your angle is given in degrees, you want alpha in degrees, and if your angle is in radians, you want your alpha to be in radians. Okay, so part 1, here we go. We're going to draw our angle of rotation. Here, I'm in standard position, positive x-axis, and I'm rotating 60 degrees. Here it is. And there's my angle of rotation. That's theta. Now, if I want to draw the reference triangle, I have to drop a perpendicular. Okay, so here it is. I'm dropping a perpendicular because a reference triangle, that's really hard to see. Let me fix that. This angle of rotation is 60 degrees. So I'm going to make this 60 down here so you can see it's smaller. Okay. And then I'm going to draw a reference triangle. And it doesn't matter how long your side is here. I'll make my side longer here. Okay. Now, a reference triangle is nothing more than a right triangle that you create with the horizontal. Okay. So here it is. I'm drawing a reference triangle. Dropping my perpendicular, you always drop it to the horizontal. Now, this triangle right here is my reference triangle. I'll do it in green here. This is my reference triangle. Okay. And inside the reference triangle, the angle that your triangle, the terminal side makes with the horizontal is alpha. So this is alpha. Okay. That's alpha. Now, in this case, does alpha equal theta? And alpha in this case is 60 degrees. Yes, it equals, in the first quadrant, your alpha, your reference angle will always equal your angle. Okay, so let's go over that really quickly again. The reference triangle is the triangle that you create when you drop a perpendicular from your terminal side to the horizontal side. So this right here is your reference triangle. Okay, alpha is the angle between 0 and 90 degrees, or 0 and pi over 2, that your terminal side makes with the horizontal. Okay, so we didn't name the quadrant yet. So this is quadrant 1 angle, and I drew the reference triangle, and I've got my reference angle of 60 degrees. So I've done what I needed to do. Okay, so part B, 3 pi over 4. Well, here we go. Here's my initial side, and I'm going to rotate 3 pi over 4. Well, in my mind, I know this is pi 0 and this is pi, and I know this is pi over 2. Okay, and I'm in fourths now. So if I go 1/4, 2/4, 3/4, 4/4, I know that I'm going to be in the middle angle here. And my angle of rotation theta is right here. Okay, so I've drawn my angle of rotation. My terminal side is in quadrant 2, so this is a quadrant 2 angle. And I'm going to create a reference triangle. How do we do that? Remembering that the reference triangle is the triangle created when you drop a perpendicular. Here it goes. I'm dropping a perpendicular to the horizontal. Okay, and alpha is the angle inside the reference triangle that's made with the terminal side and the horizontal. So this here is alpha. So theta is not equal to alpha, but alpha is the angle inside the reference triangle that helps us figure out what our sine, our cosine, and our tangent is, because we have a right triangle here. Okay. So what is alpha in this case? Well, I have to be in radians. So what's the distance from here to here? Well, it's this. Remember, this is 1/4, 2/4, 3/4, 4/4. So this distance here is going to be pi over 4. So my reference angle is pi over 4 radians. Okay. All right. So now I think you guys can practice these and draw those, okay? And then number 2 says for each quadrant indicate the signs of 3 trig functions. Well, we just have to go back to our unit circle, and you'll figure out that the cosine's, positive in quadrants 1 and 4. The sine is positive because remember the cosine is the x. Cosine's positive in 1 and 4, sine's positive in 1 and 2, and sine's negative in 3 and 4, and cosine is negative in 2 and 3. So that just takes some time to digest that information a little bit. Okay, the next problem I want to do with you is to do one of these. Okay, and I want to do C because it's in not in quadrant 1. Okay, so what we're going to do, the instructions are sketch the angle of rotation whose terminal side passes through the given point. So that's what I'm going to do first. So I am given a point, so let's plot that point. 1, 2, 3, 4, 5, 6, 7, -2. There it is. There's my point. And my angle of rotation, it says, passes, and the terminal side passes through the given point. So my terminal side of my angle passes through this point. Now I didn't pass through there very well. But so my angle is this. So this is my theta, right? In standard position, that's my theta. And am I passing, is my terminal side passing through the point 7, 2? Well, -2, the answer is yes. Now I'm going to draw the reference triangle for this one. Well, remember, the reference triangle is created when I drop a perpendicular to the horizontal. Well, in this case, I'm going to have to raise up the perpendicular. So there it is. So this is my reference right triangle here. And now I know that alpha is right here, don't I? Because alpha is inside your reference triangle, and it's the angle that your terminal side makes with the horizontal. Now, alpha doesn't have any rotation to it because it's just an angle inside the triangle, okay? All right, now I want to find, well, actually, my angles are x, so I should label this x instead of theta, right? This is angle x. Well, I need to find the sine of x, the cosine of x, and the tangent of x. Well, in order to do that, I need some side lengths. Well, if I know this point is 7, -2, I know this length is 7. In which direction did I go to go down? I went down, right? So this is -2. Now I'm labeling that -2, not because the side length is negative, but that's the direction I went when I was, going to my point, okay? Well, the sine requires the opposite, and we use alpha as our reference angle for x, because we need that in our right triangle. So the sine of an angle is equal to the opposite of the hypotenuse, but wait, I have no information here. So I got to solve for the hypotenuse. So I'm going to say c squared equals 49 plus 4. C squared equals root 53. Okay, and I can't reduce that. We're stuck with it. So this side here is root 53. Now I didn't go any direction on this hypotenuse, so our hypotenuse numbers are always positive. Okay, because that's just a length of a side. I didn't go any direction. Our path is determined by the x and the y. So the sine is going to be -2 over root 53. Our cosine is going to be 7 over root 53. And the tangent is going to be -2 over 7 if I do opposite over hypotenuse. Now I can rationalize these by saying -2 root 53 over 53, and this would be 7 root 53 over 53, and I don't have to do anything with this one here. But let's see if that makes sense, knowing what I just learned about the unit circle, right? I expect in quadrant 4, because my angle here is quadrant 4, I expect that the x is going to be positive and the y is going to be negative. And remembering that the cosine is the x and the sine is the y, let's see what happens. The cosine, is that a positive number? Well, yes, it is. And the sine, well, yes, it is. It's a negative number. And then the tangent, which is going to be the y over the x, is a negative number, which makes total sense. Okay, one more example. And this is Roman numeral 5. State the measure of the reference angle alpha for the given angle of theta. Okay, now I'm going to do this one here, letter C. So if I were to draw my angle here, 135, that's 135 degrees right here. That's theta. I need to have a reference triangle. So here it goes. I'm going to drop perpendicular. There's my reference triangle. Alpha, which is my reference angle, is right here. So if theta's, oops, I went the wrong direction. Gotta fix that because I went negative. Can't go there. Okay, here we go. I just watched myself do it too. Try to be perfect every video. Never works out. Okay, here we go. So there's theta. I'm going to raise my perpendicular to the horizontal. And then this is alpha. So if theta is negative 135, alpha is the angle between, in my reference triangle here, between the terminal side and the horizontal. So alpha is equal to 45 degrees. So all you have to do when you want to find your reference angle is draw your angle and figure out what the angle distance is from your terminal side to the horizontal. And remembering that alpha doesn't have a sign, like a positive or a negative with it because it's inside a triangle, and that we're just using that as a reference angle. Okay? All right. Well, thank you for listening, and I hope you have a great rest of your day. Thanks.